My name is Ricky Uch, and I'll be presenting my final course project for CS410 Text Information Systems for the University of Illinois Urbana-Champaign. So to get started, I'd like to give a general overview of what the system function is. So it's a beer recommendation system. Its primary function is to recommend a beer based on a user's prior history of reviewed beer and feedback that they've previously given on beers they have drinking. So these feedbacks would be in the form of quantitative ratings across common beer attributes such as aroma, text, taste, palate, and also, in addition to that, forming a recommendation based on actual free text feedback they've also given on the beer. So what's the reason for this too? What's the purpose? So in general, there's a wide variety of beers. Being able to narrow down to a set of beers or a beer that you'd most likely enjoy based on your beer history is it's not quite tangible by simply drinking every single beer. There's quite a large variety of beer. It's just not the most effective way of trying to try every beer that's available to you. So being able to have an application that can kind of narrow down the beers for you would be quite useful. So I think the most common scenario that I've come across as an avid beer consumer myself was I would go to a tap room. There'd be a list of 20 or so beers, either on a beer board or perhaps even in a menu. And the common question you'd ask yourself is like, which beer should I have? So getting to a beer that you like is not the most easy choice. A lot of times you have to go through several tasters and try a lot of different beer, and it's just not efficient. So being able to narrow down from this list of 20 down to one where you know that you most likely like the beer that you're buying is probably most efficient, most cost effective. Similar scenario when you go to a beer retailer as such as Total Wine. You'd be faced with a large inventory of beer, and due to the volume of beer itself, it'd be very hard. You'd be shopping for quite some time, trying to introspect every single beer label, quickly querying the beer description on a beer website such as Beer Advocate or some other beer website, and try to make a guess based on what you think you'd like. Having an application handy where you could just simply say, input this beer that I found at Total Wine. What's the likelihood that I would like it? Knowing that the application has some type of intelligence to kind of use your own beers that you've had previously and make reviews on to kind of arrive at kind of a recommended beer. So that's kind of the general usage of this and utility of this application. As far as comparable tools to the applications I developed, there are tools out there. A big application that is out there is a mobile application called Untapped. So they do make recommendations based on a rating system and recommend a beer based on that rating system. Kind of how my application is differentiated from that is that this one will combine the same like quantitative ratings and combine it with sentiment based on your actual textual feedback that you're given for a beer. So that's how it's different. So mine's more of a hybrid of quantitative ratings in addition to kind of sentiment based on how you've written an actual textual review. How I implemented this application was I was able to get an extract of beer review data from the Beer Advocate website. I found it on the Data World website, which has been quite a handy tool for finding a lot of different disparate data sets for these types of analyses. So I was fortunate enough to find an actual beer review data set that was large enough in volume to actually build my recommendation system. So I used this data to form the seed data for the recommendations. As far as the actual coding libraries that I've used, I used a scikit library called Surprise, which was specifically developed as an open source library for recommendation systems in mind. So they have a lot of inherent tools to be able to deploy different algorithms, training, training data sets, as well as even evaluation metrics to kind of determine how effective your algorithm was on a given data set. For sentiment analysis, I use the text blob library. They have in their library functions that are able to extract polarity values, which more or less specify a sentiment score for a given input of text. So I was able to kind of leverage that library and kind of integrate it with the surprise Python scikit library to build out kind of a scoring mechanism that is a hybrid of both ratings as well as data information based off of a text review. So let's go into the demonstration of my software. So my demonstration is basically going to show you after you've kind of deployed and installed my tool onto your local machine. My demonstration kind of assumes that portion already. If you need steps, those will be handy in the README file on my GitLab. So I'm going to go over to my PyCharm and give you a demonstration. So what you see here is in PyCharm, the code's already been deployed on my own local machine. There's really just one script that you'll be running primarily. It'll be the surprise POC. In the course of this project, I was actually testing out different recommendation frameworks. So that's why you'll see that there's a light FM POC and a surprise POC. So that was the basis for my technical review. I actually ultimately ended up using the surprise toolkit, mainly for its ease of use and a lot of inherent features that made it quite easy to kind of build out this algorithm. There's a lot of great functionality and a lot of evaluation metrics and tuning things of that sort that are inherent in the surprise toolkit. So let's get started. So let me ensure that I'm actually in the right directory. So you'll need to be in the surprise POC directory where my scripts live. So let's open up this. So we'll be running a script called beer surprise underscore POC. Beer surprise, oops, POC. And what my application will do is it'll actually take as an input a JSON configuration file. So that's how you would feed a request to get a prediction. So I've defined a series of different parameter values that you can pass into this application. So kind of the three main requests that you could submit are, one is my name is username XYZ. Give me some beer recommendations. Give me 5 recommendations based on what I previously drank and in terms of beer and offered feedback on. And then it'll return back 5 beer recommendations based off of what you've drank and what you haven't drank. So the 5 recommendations would be net new beers that you haven't tried. These are the best ones that you should try. Secondly, what it also can do is, and this was with the mindset of having going to an actual tap room. You have a fixed set of beers offered to you. Out of those fixed set of beers, which one am I most likely to enjoy? And then lastly is kind of like the last scenario where you're at Total Wine. You grab something off the shelf. The label and description of the beer sounds good, but you kind of just need that extra information in the form of this recommendation system to see what's the likelihood I'd enjoy this beer. So that's kind of the last one. And I'll walk through each of those scenarios with the configurations I have. So the first scenario I'm going to walk through is I'm a given user, give me a set of beers, recommended beers. So I'm not specifying to the system what the beer should be. I'm just saying I'd like to give me 10 recommendations that I haven't had before. So I'm going to this config JSON file. So within the configs folder in my overall project, I have a set of 3 distinct JSON files. This config JSON file is kind of used to represent, give me 5 recommendations for this user. So as a parameters, I've defined this user for read drover. So he's actually a user within the Beer Advocate dataset. His number of reviews is a parameter that I put in specifically because since this application is deployed locally, it was very hard to kind of know what the underlying platform for each user was going to be. So this is kind of like a configuration to throttle the amount of reviews that actually the model will be trained on. The actual Beer Advocate dataset's roughly over 500,000 reviews. I'm not going to put 500,000 reviews because the model will take a very long time to train, and I just wanted to demonstrate the utility of this. So I'm just going to set at 10,000 reviews. So the model will be trained on 10,000 reviews. And then the number of reviews the number of recommendations I would want back out of this recommendation system is 5. So after I run against this config JSON file, it should return me back the top 5 recommended beers based off of Reed Rover's review profile. So let's run it. So I'm going to put the config.json file as a parameter. So basically you will pass in the JSON file as a parameter, and then you would run this piece of software, and we'll see the outputs. Okay, so now it's running. So it should return relatively fast since it's being trained on 10,000 reviews. So by default, if you don't supply weights in this parameter file, the default weight system would be 0.3 for the quantitative ratings and 0.7 for sentiment. And I'll kind of talk through what that actually means in terms of formula. All right, so as we kind of see, as we kind of look through the terminal, by default, it'll show the outstanding beer reviews that the given users has made reviews for. So you see there's a series of different beers that Reed Rovers tasted and offered feedback on. And then because I passed in 5 in my configuration, it returns back 5 recommended beers. So the rating scores kind of show kind of the overall scoring in terms of the likelihood of how you liked it. You would like these recommended beers. And then you see that there's these 2 messages saying no individual beer submitted for prediction, no beer list submitted for prediction. And that's just because I only specified these 3 pieces of information in my request. I'll walk through how to submit the request for individual beers and a beer list. And then lastly, the output of the application will show the actual evaluation metrics of how effective your algorithm was on the training set. So generally, the metrics that are out of the box that are displayed are the RMSE and the MAE. You'll see that they're relatively low, which is pretty good. So yeah, and then fit time, test time. So that's why I used the library toolkit. A lot of this was using already built functions from the library, and more or less I just was creating the rating mechanism for beer, loading the data, and then calling these functions to arrive at predictions. So now I'm going to walk through how to actually request a prediction for a beer list. So again, similar configurations, mandatory parameter, you have to supply a user. Obviously, you can't get a recommendation without a user to get the recommendation for. Number of views, again, it's a throttle. It's not mandatory, but I do have it just in case you need to throttle it down, or if you want to scale this up. If you want to get kind of more robust data, you could scale it up. I'm just gonna leave it at 10,000 because I know that on my machine, I know it runs relatively quick. So these rating weights, by default, as I was saying earlier, you could put 0.3, 0.7, as long as the combined weights of ratings weight, text sentiment weight equal to 1, you should be fine. Just for the sake of it, let's just change this up. I'll put it to 0.7 and 0.3. And now instead of offering back a set of beer recommendations, I'm going to actually tell it, I have this given set of beers. Give me the predicted score for these. Like how likely am I going to like these beers, and which one of these three am I going to like the most? So I'm going to again rerun the script. So Python beer, and then now I'm going to pass in this beer list config JSON, beer list config JSON, and now I'm going to rerun the program. I'm just going to go through. Again, it'll also show what Reed Rover's previously rated in terms of the beers that he's reviewed. And then now you'll see that instead of beer recommendations, it's actually giving me a score for these set of beers. So out of these three, it looks like Belgu Magus is actually a highly recommended beer. So generally what I've noticed is based on kind of the scoring that I've set up for beers, generally if you're 0.5 and above, it's a pretty solid beer recommendation. Below 0.5, it's not as much. The scores will range from 0 to 1 based on the formula. I've normalized all values to be between 0 and 1. And then you'll see that again, it'll calculate the RMSE, MAE metrics for the evaluation. Okay. So lastly, I just wanted to show how to submit the request for an individual beer. So the total wine scenario where you're in the shop and you're just curious about a beer. So if I go to this individual beer request, let's change the user. Let's go with John Michelson. Again, I'm just gonna leave it at 1,000 or 10,000, excuse me. Ratings weight, let's go with this. Let's the 0.3 for ratings weight, 0.7 for sentiment weight. And then the beer in question that we want to get a prediction on whether I'd like it or not is this Hop Dam Triple IPA. So we're going to submit this JSON as a parameter, individual, hopefully I spell it correctly, beer request JSON. And let's see what the output is. So thinking about I misspelled this. Individual. There. So I do have error handling. Fortunately, I have error handling, or else it would be kind of a pain trying to troubleshoot a stack trace. So now it's running. So you'll see the list of beers that John Michelson previously drank, and sentiment scores, the actual rating score, which is based on a formula that I actually created specifically for this project. I have more detailed information on what that formula is in the PDF that's in my GitLab. Okay, so for the individual beer, so this Hop Dam Triple IPA, we see that the predicted score is 0.429. So it's an okay beer. It hasn't, it's pretty close to drinkable, but not quite there. Again, this is just going off of the baseline of 0.5 generally means it's a beer you should definitely try. Less than that, not as much. Okay, so let's get back to the main part of my presentation. So let's go to the results. So a lot of this is kind of based on judgment. When I was kind of running my application to various users, I kind of know beer well enough to know if the results made sense. So for example, cross beer, there's kind of a few broad categories you can put people in. Some people like very hoppy IPAs, other likes very like dark stouts, others like very brown, like brown nutty beers. So kind of just based off of just my own domain knowledge around beer, I would generally look at the results and see if those recommendations made sense for this given user based on the beers that they previously reviewed and liked. For the most part, they're pretty close. I'd say a good out of maybe 10 recommendations, I think 6 of them would probably um, be actually accurate. There were some anomalies where, for example, it was very clear that the user was very much into kind of like dark stout beers, and then for whatever reason, the recommendation would return a lager. So it's not completely foolproof, but it's pretty accurate in terms of actually getting the majority of beers correct in terms of what a user would like. Um, Also, what I found in terms of machine learning, this is actually my first foray into um, machine learning of any sort, um, was the underlying hardware actually makes a very big difference in terms of performance. I tried running this against the complete 500,000 beer reviews, and my machine would kind of just hang and hang and hang, and just I couldn't wait for it to finish because I needed to kind of develop on this project. So and hence that's why I put the mechanism to throttle the number of views that would actually be used in the training. Um, so yes, sorry. So let's future improvements for the application. I think for practical purposes, this app would actually make more sense to be deployed on like a mobile application on iOS or Android. A lot of times, the scenario will come up when you're out and about, so you're not going to have obviously your laptop with you to run this app. So having it on a mobile device would actually create a lot more adoption. I did it as a command line project because just for logistical purposes of actually getting the project executed for per the deadline, that was the best way. But if I were to deploy this to the public masses, I want to deploy it on a mobile application, as a mobile application. And also other features that you'd be able to leverage, and this is kind of more long-term thinking, is you're not likely to type an entire beer list into this application. The more likely scenario is that you'd probably use your phone camera, capture a beer list on the board, or perhaps you're just taking a photo of the actual beer menu itself, and then use image recognition to extract the list of beers for the beer recommendation. I think that's probably will yield higher usage of the app. Um, um, and then further enhancement would be based on beer recommendations. So this is kind of the first scenario where you just kind of just want top 10 beer recommendations. An extended functionality would be based on the 10 that were returned to you, the 10 recommended beers that were returned to you, kind of query against various bars, retailers that are kind of in the surrounding location, and see which of those locations would actually have those beers on tap so you can go out and try it, right? Having a good, like this set of beers in kind of this kind of scenario type setting is great for knowledge, but how do you actually take action on it? So being able to kind of see which potential locations has the recommended beer would be kind of the next evolution of this app. And lastly, and I tried to kind of demonstrate this, maybe it wasn't quite explicit, was deploying the actual recommendation system as an API endpoint. I tried to kind of emulate that process by having a JSON being fed to as a parameter in my command line. That was more or less kind of emulate the process of submitting an API request payload and getting results returned back, preferably to like a mobile application. So that's what I would do to kind of scale out this application. So I think that would make the most sense. And lastly, I think if I had more time to actually enhance the app, I would also probably dig more into the actual textual review process to kind of get a little bit more accuracy in the beers that were recommended. As I was saying earlier, there would be some times where there were some beers that were recommended even though they weren't quite an exact fit. And I think kind of getting more into the text review feedback would identify a little more insight in terms of kind of the flavor profile of the user rather than just basing it off of their individual ratings and um, just overall sentiment, which more or less just tells like, oh, was this beer kind of bad, neutral, or good? So anyway, so that's the end of my presentation. If there's any additional questions, I do have further documentation in terms of how this application was developed. The code's available to scan through. I'm available on the Slack channel for our class. So if there's any questions, please feel free to reach out. Thank you.